Quiet. Have your sheets out, have your memo page out, and something if you want to take notes on. Remember, don't ever take notes on your memo page. You'll know you should write something new on your memo page when I've taught it. Then most likely I've taught you how to memorize it. And so it's just a reference. Look at it every time you do your homework, and eventually you'll find yourself not having to look at it. That may even happen on your homework some on Delta Math. I don't know if you were calling some of these to mind. But anyway, we will write on the memo page today. In fact, why don't we start with the IOU chart? Some of you, if you listen to a little short video I sent you, know what to do with what we call quadrantal angles. And I explained it a bit in the video of why it even makes sense. Remember how I've said that we are moving away from geometry and into trigonometry. And so the way for us to do that, one big way for us to do that is this. All of this is well and good as we go around the circle, and we can tell people where we are based on the X and Y coordinates, where we got our All Students Take Calculus acronym from, okay? Remember, that tells us where things are positive. We'll review that today. This is great if I call this X, Y, and R. Those are our old friends, the opposite, adjacent, and hypotenuse, right? Okay, so then I moved you a little bit from opposite over hypotenuse, and you'll have to always know that sine is y over r, and cosine is adjacent is going to be x over r, and tangent is opposite over adjacent. You can already imagine why this is important, and there's going to be x and y components everywhere. Even your position is, you've heard of like coordinates that somebody sends, those are really coordinates that are similar to these. And so what I want you to be able to do is literally find sine, cosine, and tangent eventually, even if I just give you 1 point, okay? So I'll tell you what, let's do that right now. Get out your calculators. Now all of a sudden, for the first time ever, it matters what mode you're in. So everybody get out your calculators. Always have them with you. Good.
Can I borrow one? Mine is charging.
Okay. So go to mode, and now you're going to have to be super careful in homework and tests that you're in the correct mode. Right now we want to be in degree mode. Okay, do you see mode? Go down and make sure the black box is over degrees, and then go back to your home screen. All right, now don't do anything with it yet, just watch this. There's going to come some homeworks soon where if I give you like 2 numbers, let me see if I want to start here. Yeah, I might as well go ahead and go big, okay? So this is an X and this is a Y. And does anybody know how I can find the radius? If you're not going to draw a picture, you're not going to have any of this. I just give you a point. Obviously you have X and Y. How can I find R? The Pythagorean theorem. Katie's mumbling a squared plus b squared equals c squared. Now, don't we know that from all of these pictures that we've been drawing? By the way, what quadrant is this angle going to be in? What did somebody do? Second quadrant. Great, Zena. So second quadrant, okay? That's going to be important later. Do you see how Zena knew that? Now, all of a sudden, she can see position. Are y'all okay if I just go in and say the radius is 5? This is a 3, 4, 5 triangle. But I would go a squared plus b squared equals c squared. Make sure you are actually putting in parentheses. A squared plus b squared. I always do it this way, though. I'm going to move away from a, b, and c and move toward trig. I'm going to call it x squared plus y squared equals r squared. If you look at the picture, x squared plus y squared is going to give you the radius. Rebecca, is that your hand?
Yeah, can you just assume that the origin is like the origin?
We're starting at 0, 0's in the middle. Is that what you were asking?
Yeah.
All right, so now I can just go sine of theta is y over r. Cosine theta is x over r. And tangent theta is y over x. Do you see how quick that was if I don't have to draw a picture and everything? Now, people are going to get on a test or a quiz or doing homework and kind of reminds you sine is y over r, cosine is x over r. I can remember, because they go in alphabetical order, like cosine comes in alphabet before sine, and x comes in alphabet right before y. Okay? Another way to pull yourself out of confusion, because I'm always teaching you where you understand it, and hopefully your memorization skills, just like multiplication tables, are going to help out. I even still see some students add together on their fingers. But it's nicer if you have memorized, right? Then you don't, like 7 plus 3 is 10. You don't have to add it up on your fingers, okay? But anyway, your memorization obviously is going to be your friend. But you could always just slap a little triangle up here and think about it for a minute. Do you see you could pull yourself out of the funk you might be in if you've forgotten sine is y over r, cosine is x over r. Do you see that reminds you opposite of over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You just put that maybe at the top of your page. You can keep looking at it on a test or a quiz. Okay, but do you see how nice that was? Because I memorized it and you will also. Now, does anybody know, Rebecca I think brought this up the other day and then somebody knew what it was. I can't remember who gets credit to. Maybe it's Bella, I don't remember. How can you find the angle? I don't know what the angle is. Jane and I know what's in the second quadrant. Bella, what can I do?
You can use the like the sine -1.
Okay. Now, I'm not trying to take the cosecant of this. Do y'all see the cosecant of this would be 5/4? I'm just going to flip that over, okay? I'm actually trying to find the angle, which is a lot more intense. It's what Bella's referring to as an inverse function. I don't know the angle. Usually I know the angle and I find the ratio. What if I have the ratio and I'm looking for the angle? So now let's push inverse sine and look what it gives you. You go second sine. Sorry, that's mine. Second sine of 4/5. 53 degrees, but Zayna and I know it's in the second quadrant. So what's it just able to give me? A reference angle. I hope that you know as it spins around and hits 53 degrees, you would get a sine of 4/5, but in the second quadrant, sine's also positive, and then it happens over and over again no matter where you rotate. So do you see it's technically impossible for it to give you every angle that could happen, so it just sort of helps you out a little bit. How could you find the actual angle in the second quadrant? Perfect. 180 minus answer. 180 minus 53.13 is
126.9.
126.9-ish. You'll always give me 3 decimal places when you're doing this. Now, here's something interesting. And before we do it, I'll kind of give you, this is not even a lesson for today, so we'll stop pretty soon and go to what I really want to do today. I'm kind of just reaching out my head. But it just came up naturally. Cosine, all students take calculus. All right, so if I have they're all positive right here. And then students take calculus. Look at what cosine is. Cosine's negative. That doesn't happen here or here. Do y'all see what I mean? So if you were the engineer in charge, and now these two angles and many, many more actually have that cosine. Do y'all see what I mean? It's not unique, all right? It's interesting. It has unique qualities, and then it has to be 53 degrees away from the axis. But if you were in charge of programming your calculator, and you wanted to put the first one in that became a negative, which quadrant would you put in? If you were in charge, which one would you pick?
The angles then?
Yeah, they got to program a way. They will start to tell you where things are negative. So you'll see they picked the second quadrant. Why pick the third quadrant? They'll just pick the first one that you would come to where sine is negative. Do y'all see the danger that could be here?
Yeah.
Like Zayna and I might know we're in the third quadrant. Meanwhile, our calculator's giving me angles in the first and second quadrant. I've got to use my reference angle to put myself where I need to be. So again, you know, you even know the discrepancy of some teachers letting use calculators and some not. I think my point is, you've got to know your math maybe better to use your calculator. You've got to really understand what you're doing. In any event, push a second cosine of negative 3/5. Did it give you the same angle?
Yeah.
Why did it go over and travel into the second quadrant? It's because it was looking for the first thing it came to where cosine is negative. And so it goes like this. Okay? If that all seems really super fuzzy, you're in the right place. There'll be another day that we talk about that, but you'll see if you take AP Copy C, when we're moving really fast, a lot of times I just lay a little foundation, just to like ruminate in your head to where when I really teach it, it makes a whole lot more sense later on. It really weaves into what we're doing today. Questions on this? Okay?
Mine's kind of related to this, but it was like on the delta math. Like, how do you know when the answer is going to be negative?
By the quadrant because all your delta math, they gave you the angle.
Yeah.
So you know by the quadrant it lands in. Use this, all students take calculus.
Okay.
And so if you have something that lands in the third quadrant, this T tells me that only tangent is positive. That means by default sine and cosine are negative.
Oh.
And their reciprocals follow suit. Okay?
Okay. Wait, so
There's a bunch of O's there, okay? So if I land in the second quadrant,
only your sign is positive?
and that means by default cosine and tangent are negative.
Okay. And then if it's in the first quadrant, they're always positive.
Right.
Okay.
And so what I mean by this, as soon as I see sine is positive, its reciprocal cosecant is also positive. So some of you may, since it's grade O delta math, you may have just sort of guessed different things until you got it
I
right.
would try positive or negative.
There's a way to know, okay? Thank you, Elena. Does that help y'all?
Yeah.
Okay, which I threw a lot at you in the last class, so please ask lots of questions. And now I'm so glad y'all brought that up because the whole class kind of needed to hear that. When I extremely fast taught you this, all students take calculus, I may have made, I hope I made the point that that's anyway, just trying to be cute and drag it over. That's a plus sign. And then, so it's telling you where things are positive, okay? It's a really cool thing. I don't even think I had that when I was in high school. I think this is an acronym I heard later on, okay? So that's where it's positive, and if tangent's positive, it's reciprocal. Cotangent, of course, would also be positive because all you're doing is taking the reciprocal, okay? All right, so what are we going to do today? We're going to learn something super cool called radians. It would be like if you've learned the English system of inches and feet and yards, and I really am trying to sell you on the metric system is better, which it is. Okay? I think all of us have probably go through a time where somebody tried to force us to learn the metric system. That happened to me in the 5th grade. And then again in my science classes. I never really took, I'm not super good at it still today, but I do totally believe that it's more universal, and it's a whole lot more useful because you're just moving decimals back and forth. You're not multiplying by numbers like 12 and 5,280 and stuff like that, okay? Radians are much better. I wish that somebody had even introduced you to it before degrees. I'm not sure why they didn't. What's funny is you'll find in a few minutes that you've been using radians all along and you never knew. Okay? Did you see the options in your calculator to be in degrees or radians? Which one's bigger, an inch or a centimeter? An inch is a good bit, 2.5 times bigger than a centimeter roughly, right? An inch is bigger than a centimeter if you're looking at it on a ruler, okay? A radian is much bigger than a degree. A radian's about 60 degrees, really a little bit more like 57 point something. Every time you move 1 radian, you've moved about 57 degrees. So you better be in the right mode, because if it thinks it's finding the sine of 57 radians, it's way different than finding the sine of 57 degrees. Just like if I said, oh here, measure this, and I want you to cut me a piece of wood that's 3 units long. It makes a big difference if I mean 3 feet or 3 meters, right? Okay, so it's a huge difference. Now radians really make a whole lot more sense than degrees. You could have already seen them by now. I actually introduced it in my geometry classes, but I don't think my students that taught geometry remember. But anyway, so this you really will have to deal with. It's really cool. I'm going to draw a picture of it, and then I'm going to give you some animations that do a much better job of this. A radian is better because it really is using the radius of a circle, okay? So here's a radius of the circle. That's R. It spins around like this. And the years that I've taught only on a whiteboard and not on a smart board, I'll go over to the whiteboard before these other cool animations came out, so I'll show it to you with a computer animation instead. But I kind of hate that I don't still do this. I used to take time to get a protractor, a compass, and draw a good circle. And then up on the board, I had one of those big teacher things, you know, and then I would get, I would just pull out a long piece of yarn or string, and I'll call a student up so that they would know that, like a magician, you know, that I'm not just messing around, that I'm not making it up as I go. Usually I would even have a student draw the circle to where I'm not even in charge of it, to where you can't think I'm being tricky, okay? So you can imagine I could have a student come up, draw a circle. Then we could find the radius together by the little point on the board that was the center. Could use a ruler to find the radius. And then we could cut the string to get the length of the radius. And then I take that string and start wrapping it around the circle. I'm wrapping the radius around the circle to see how many times it goes. You've all done this before. You'll have another aha moment. You've done it because I know that, like in the upper mid, you probably have the little pi day. You probably did something like this, okay? It's really true how this works. Students a lot of times feel kind of sorry for me because, you know, I do crazy things and sometimes they don't work out so well. Usually if you ever see me with like cut up pieces of paper and I have this like wonderful, intricate, fun thing for y'all to do, you might remember with me that usually goes around really fast. I usually haven't counted the little slips of paper right, or if you ever think you're going to get in groups and do something with me, it'll probably fall apart. But anyway, I'll take the radius and then I'll start to wrap it around the circle, and people are like, oh, poor Miss Lazari, because it'll go like 1, 2, 3. And they go, I bet she wanted it to be 3 completely. But it's not. It never is. And I've done it a million times. And then I'll keep going with the radius. So this is 4, 5, 6. How far is this? That's 3.14 every single time. It's amazing that ratio happens every single time. So what is pi? How many radius is it? It's a little more than 3, right? That's pi radians, actually. Somebody said pi right away. It is actually 3.14. You've probably done similar things like this maybe on Pi Day. But anyway, that is actually, unfortunately, 3.14159 radians. Okay, so how many radians? These are radians. Do you see the word makes perfect sense? You're counting by the radius. So it's 3 radiuses and a little bit more. And so how many radians is this? This would be 1 radian. How many radians is this? This would be 2 radians. And this is 3 radians. Now it becomes paramount that you put a degree circle if you're talking degrees, because there's not really a symbol for radians. We just don't even write the degree circle. But if you write down 30, I need to know if you mean 30 radians or 30 degrees. Do y'all see how big a radian is? But you see also, you'll really like this. Let me keep moving. So this is how many radians? 4, 5, 6. So how many is this? 2 pi.
There's a word for it, right? For like double pi. Never.
Maybe. Let me know, okay? All right. Watch this. You just told me there were 2 pi radians around the circle. What was the radian? It was actually the radius. What did your teachers teach you? The formula for circumference of a circle? They didn't teach you anything about 360. Isn't 360 all the way around the circle? You should have been a little curious about that. If they're going to give you the circumference, you would have gone all the way around 360. They weren't working in degrees. Your teachers were working in what? Radians. Because it's actually 6.28 of those radians will make a complete circle. So we're talking 2 pi. If you say 2 pi times the radius of the circle, you'll always get the circumference. That's what it is. Isn't that neat though? You know, some of you do it, but I think that's really cool. All right, so you've already been working in radians, so just kind of calm down. Okay? Link?
So like 3.14 R is pi.
3.14. Okay, if you're measured in radians, it's pi. I can have pi inches, I could have pi degrees. I can have 3.14 degrees. But if you're measuring in radians, if you're measuring in radians, it always ends up being 3.14 radians halfway around. A little bit more than 3. It'd be a whole lot easier for us human beings if it was just 1, 2, 3. But things like that don't ever work out in real life. It's a little bit more, and not only is it a little bit more, it's this number pi that's been known for centuries. Okay. Oh, and by the way, there's many other ways to actually prove this 2 pi r. I think it was Aristotle did it by the method of exhaustion, where he divided up into tons of little polygons and added them together. I can also do it in calculus, dividing it up into a bunch of rectangles. And find every time anybody does it, they get 2 pi r. By a different method, you're going to get 2 pi r. Let me show you these animations now. All right, they're under topics. One of them Ms. Arkin just gave us that is really good. And so I think I have them here. All right, so this is kind of the same thing as wrapping the... So there's the radius of that circle, and now the computer program will take that radius and start to wrap it around. One radian, or in other words, one radius. Do you see it's a little bit around 60 degrees every time you move? There you go. 3 radians. That's pi radians. And all the way around is 2 pi. Okay? All right, and then look at this one that Ms. Arkin showed us a while back. It's really cool. We might, I don't think we'll have time in honors pre-cal to make it, but we might get our, I might get my regular pre-cal class to do the Fab Lab with this.
I'm on it.
Are you're, she's
I'm on
already,
it. I didn't start it yet, but I'm on
you know how to do it?
it. No, we're going to try and do it upstairs.
Okay. Yeah, I think we might do it with our pre-cal classes. Oh, let me. All right, so there's 1 radian. You see how they keep showing you they got the radius? And then as they put them in, you can kind of see from the slices. If we actually make one in the Fab Lab, you'll see that we'll need, we'll have little gaps because there'll be more than 6.28. Okay? All right, now let's get our conversions. Halfway around is how many radians? 1 radian's right here. Halfway around is how many radians? So let's say pi, right? A little more than 3. All the way around is how many radians? 2 pi, okay? So you'll get instinctive about it to where it's just natural for you. If I say show me 180 degrees, if I say show me pi radians, you'll be able to do the same thing, okay? Now, you know how 3 feet equals a yard. And I'm doing this with my Algebra 2 classes right now, and you've done it in math and chemistry where you do conversions. If you're going to convert to yards, you put it this way. If you're going to convert to feet, y'all put it this way. I mean, is everybody okay with that? So you have something that's equal, like 12 inches equals what? 1 foot. And it gives you a way to convert from feet to inches, inches to feet. All right, so what's our conversion going to be? 180 degrees equals what? Pi radians. Not 1, girls. 1 radians, just imagine your circle. 1 radians just right there. It's not quite 60 degrees. Right here. I have to go 1, 2, 3, and a little bit more. 180 degrees is pi radians, 3.14. Okay? What's all the way around? 360 degrees is 2 pi radians. You can use either one of these to go back and forth from radians to degrees, degrees to radians, okay? If I want to go 2 degrees, I'll multiply by 180 over pi. Did y'all see what I just did? Okay, if I want to go to radians, I'll multiply by pi over 180. Makes perfect sense just based on all of the conversions you've ever done. if I wanna go 2 degrees, I have degrees on the top. You probably wanna actually write the word radian, I mean, I probably don't write the word radians down. How do I know that's in radians? Pi, you will start to think means I'm in radians, but it doesn't. I could have pi degrees, couldn't I? It'd be little bitty teeny tiny. That's why it's so important you check your mode. It'd be like 3.14 degrees. So the absence of a circle, and you'll know you're working with angles, you don't have to write anything. But if I want to go 2 degrees, I have degrees on the top. To radians, I have it on the bottom. And why don't I use this one? I see some books and tutoring programs use this one. So doesn't that just reduce to this one?
Yeah.
I'm just going to use this one. We'll put it on your memo page in a minute. Elena?
I'm just confused as to what you would use this in. Like, what would you use these things
I don't
for?
do any calculus in degrees. I do all my calculus in radians.
So, like, if you were trying to find an angle or something?
Yes.
Okay.
And so what's interesting in calculus is so, again, super cold, gives me more goosebumps. When you learn to take a derivative, the derivative of sine is cosine. So it's easy. You'll remember it when your teacher tells you next year, okay? The derivative of sine is cosine. You can prove it algebraically, numerically, and graphically. It's been known for centuries. But if you do it in degrees, it's not. So I'd much rather work in radians because the derivative of sine is cosine in radians. In degrees, it's 0.017 cosine. I don't want that. I don't want that decimal in my problem. So radians are really a lot better to work with. And I don't ever do, I think in radians. You will become fluent in both. It's like I'm teaching you a new language. You want it first. Right now you should be going, okay, I just got the little animation. That's the only place you should be right now. Okay? It'll take time, but you'll get there. So that's a great question. But I only work in radians in calculus. In this class and in your science classes, you'll see some of both. Actually, sometimes when somebody reports something in degrees, they actually will convert it to radians later. Get out your, depending on what you're doing, as in the circumference of a circle. What's the circumference of a circle? It's not in degrees. It's 2 pi times the size of the radius of your circle. It's the radius all the way around one time. So all of these formulas that you got, guess what mode they were giving you in? Radians. Surface area of a sphere, 4/3 pi r cubed. I can find that in calculus only if I'm in radians. So you've been working in radians all along. That's why that pi is sitting there, okay? All right, so that to give you a little bit of comfort or weird you out a little bit. Okay, so on our memo page, you're not going to write yet. You're going to wait till I box in and move away.
Wait, so Mrs. Airy,
Uh-huh.
since now we're like working with radians, should we be on radian mode on our calculator?
You'll switch back and forth. We'll work in both. So we'll talk about that a lot. If you're going 2 degrees, you take the angle that I've given you and multiply by 180 over pi. If you're going 2 radians, these can be like really small. If you're going 2 radians, you take the angle that I give you and multiply by pi over 180. All right, so now it's boxed in. While we're there, some people are still writing. Hopefully you don't have to memorize that. It'll be there for you to look at. But hopefully that makes perfect sense. I'll put a little degree circle right there. Sorry. I just put it at 180 degrees. The circle now is one of the biggest things ever. You've got to really watch and see, like Nicole was asking me what mode you're in. And you'll know by the circle or the absence of a circle. You should wonder, how do you even know if you're talking about an angle? Because I could have 3 pi feet, couldn't I? Isn't that about 9 feet? You'll know you're in an angle. You won't worry about it. It'll have sine, cosine, or tangent, or it'll say the angle is, okay? So don't get all hung up that pi over 4 has to be an angle. It doesn't. In context, it is. But does 30 have to be an angle? Does 90 have to be an angle? No, they're just numbers. So in context, 90 degrees is an angle. All right, now let's go to your IOU chart. Right now, you are just watching, okay? So that's where I got off topic and taught you something I didn't even plan to today with the point. And I forgot to even make the point that I was trying to make with the point, okay? We are moving from geometry to trig with this statement, okay? As I go toward 90 degrees, though, around my circle, something happens that is inconvenient for geometry. All of a sudden, right at 90 degrees, I lose my triangle. It shows back up on the other side, doesn't it? But it's really nice that I know this X, Y, and R business, because at that point, I can just use my point. If that point 0, 4, what must the radius of the circle be? 4. So do you see how sine is Y over R? Sine of 90 is always 1. Cosine is X over R. Cosine is 0. Tangent is undefined. Okay, and a lot of teachers teach this with a unit circle, which means the radius would be what? 1, and the point would be 0, 1, 1, 0. Do y'all see it all collapses or reduces down to whatever, to the same ratios? So I'm really glad when I get to 90 that I know that I'm going to put Y over R, because I don't even have a triangle anymore. Again, this makes sense, because as I'm getting closer to 90, what's happening to my adjacent side? It's disappearing, isn't it? To where cosine is adjacent over hypotenuse, I don't even have an adjacent side. What in the meantime is happening to my Y component? And for a split second, what happens before it appears on the other side? It's exactly the same as your radius if you think of a hand of a clock, okay? So for one split second, Y and R are the same number.
So it's not a triangle, but you can still use sine.
Yeah, that's why I'm so glad I've got this, okay? Because it's not really based on triangle. I've proven that it's X, Y, and R now. But also I teach it as if, this triangle doesn't have an adjacent side, and its opposite side has actually hit the hypotenuse, so it's not even a triangle, okay? But you better believe sine of 90 and cosine of 180 and all of that is super important. Quadrantal angles, happen a lot. Okay, so I probably said in the little short video I sent you that I really don't even use the IOU chart. I didn't learn it until 2004 from one of my students in Memphis.
Wait, that's like the 1, 2, 3 chart?
No, there's another one. There's you can listen to this video here. I don't know if you listened to it. I don't know what you did when you probably just started guessing in Delta Math then. You might want to go back and
I
look.
found it really
the
helpful
one that was
because
either
when it was gave you the exact one 90 or 90, 180 or 270.
It was
And
either
you can't
infinity or
subtract
0.
anything from that. 'Cause it's
Right, there is no
Yeah.
reference. Your reference angle is 90 degrees. Reference angles are really always acute. They're less than 90, and so you really don't have a reference angle there. So did some of y'all see the IOU chart?
That's just the one where it's either infinity or 0, right?
Or
It's the one
one?
where it's undefined 1, -1, 0.
Yeah.
Okay, so here it is. And I got it from going around the circle and showing it. If you want to go watch that little short video and assignment, you'll see it. It said, watch this here. I hyperlinked the word here, okay, to help you. You may have just skipped them on Delta Math, since the way Delta Math is, but you can't just skip them on my quiz. So you've got to understand it. I moved around the circle in all of the quadrantal angles. And by the way, you're not writing on your memo page yet, but this is how I do it. I don't use the IOU chart. If I want to find the cosine of 180 degrees, I can see for a split second, this X value is the exact same as the radius of the circle, but it's going backwards, so I know the cosine's -1. I just do it in my head, okay? I know it's a 1-to-1 ratio, but it's in the negative direction. What do I know about sine? Sine of 180, I know is Y over R. Do I have any Y component over here? So I know it's 0. So I just do it myself. Most students like an IOU chart. So in the little video, I found them all and put them in a chart. Okay? So you'll write this down in a minute, but not right now. Miss OD showed me a student that had me last year, that actually wrote U on their paper for something that was undefined, okay? You may have heard me say, if you listen to the video, U is not a thing. You have to write out undefined. It's not an I, an O, or a U. It's just a cutesy way to know it's 1, 0, or undefined, okay? So if you actually watched it, you can help me. You know what the most unfortunate thing is? You can see if you get your test and you're relying on your charts, and you can't remember if it goes 60, 45, 30, or 30, 45, 60. The only time you're not being in a world hurry is in the 45s. Okay? So always start low. Remember I said this. Always start low, low, low. Okay? 3, 4, 5, 6, 1, 2, 3, not 3, 2, 1. If you get confused and start with 3, 2, 1, your chart's all messed up. Okay? So what I mean by start low, 3, 4, 5, 6, 1, 2, 3. Same with the IOU chart. If you start with 90, everything's going to be wrong. Start low with zeros. So this is degrees and this is radians. This is going to be the first chart we put radians into. Don't write it yet, okay? By the time you write it, you'll know it. 0 degrees, 90 degrees, 180 degrees, 270. Why is 360 not there? It's coterminal, okay? All right, it goes 0, 1, 0, I, O, U, 0, 1, 0, I, O, U. The last two ones are negative. 0, 1, 0, I, O, U, 0, 1, 0, I, O, U. The last two ones are negative, and you can look at it to memorize it. I know the sign of 90 is 1. I don't have to look at it. What will you say for tangent of 90, though? Undefined. When we graph these, you'll actually see one of those vertical asymptotes in there, like we just studied. It's undefined, okay? All right, now who can tell me what radians to put out there on the side? Anybody want to try? Raise your hand if you want to try. Rebecca?
First one's 0. The second one's pi divided by 2. The third one is pi. And the fourth one is pi, like 1.5 pi.
Okay, so what Rebecca did is she knows this is pi radians. So isn't this half of that right up here? Change my color so you can see here. All right, this is pi radians. So haven't I gone halfway? This is pi over 2 radians. So each one of these little pieces gives me a pi over 2 or 90 degrees. I get 90 degrees more, which is 180. And then if I go to 270, 90 degrees more, how many of those pi over 2s do you see? Back to lower school where you're just counting the little pieces of your fraction. Don't you see 3 of those pi over 2s? So 1.5 pi, we write it as 3 pi over 2. And then how many do I have? I have 1, 2, 3, 4 of those pi over 2s. What's 4 pi over 2 is 2 pi. All right, so 0 goes with 0. You can go and write it on your memo page. Okay? 0 goes with 0. Pi over 2 is 90 degrees. Pi is 180 degrees. 3 pi over 2 is 270. I couldn't hear anything y'all said. Are y'all okay? Are you answering each other's questions?
She just asked why isn't there 360?
It's coterminal. It just starts all over again. Like you'll see the same numbers over and over again. One thing I talked about in the last class was this is repetitive. It happens over and over again.
So 360 would be 0.
Yeah, you're back up here.
4.
Like the sine of 30, if you type it in your calculator in degrees, the sine of 30 is 1/2. So is the sine of 390. Gone all the way
Yeah.
back around and landed again. Okay?
Not 450.
So what I do is I'll give you, we also have 30, 45, and 60, but you use those in other contexts. Because every time you land on one of those, you get the same numbers. Okay. All right, now look at your second page of your worksheet. And so now you can write on your worksheet, look at your memo page if you want to. We're going to do a lot of these together. I hadn't really decided for sure what your homework's going to be. I'll just see how far I get today. All right, so y'all taught me through this. Let's do it together. Number 1. Now, what is this entire page in? Degrees, all right? So sine of 150. Oh, how many? We've done 2 or 3 of these.
You did 1 to 4, but skipped 2.
Okay, let's do 2. This is number 2. Thank you. Number 2 is the well, now we know why I skipped 2. Cosine of 180. -1. All right. Now I'm going to 5. Cotangent of -240. So which way am I going? I'm going this way first. This is -180, -240. If you're really doing your homework and thinking about what you're doing, you'll get used to reference angles. You won't have to think very hard. But I need this reference angle right here. Anybody know what it is? This one's 60. You always count to the closest x-axis, right? So you went around like this to -180 and kept on going 60 degrees more, okay? And so now I've got to go really slowly. I've got to look up the tangent of 60. Tangent of 60 is square root of 3. You can write the reciprocal of that as 1 over root 3 or root 3 over 3. I don't care. And don't ever pull anything out of the 1, 2, 3 chart without checking the All Students Take Calculus. Those 2 charts go in tandem. They go together. Do not ever take anything out of the 1, 2, 3 chart without thinking about its sign. All students take, I'm in the second quadrant. Sine is positive. So what does that mean tangent is? Negative. Okay, you'll get a lot faster, but don't get faster right now. It's okay. All right. Let's go and do number 6, secant of 300. What word are we going to look up instead of secant? Cosine. There's probably a few students that know my reference angle here. 60. All right, so you're looking up cosine of 60. Nothing wrong with writing yourself some notes. It's 1/2. Secant is 2, but what have I not checked yet? My sine. All students take calculus, it's positive. Okay, let's do number 7. Cosecant of -60. All right, well, obviously my reference angle is 60, right? Okay, the sine of 60 is square root of 3 over 2. You can flip it over and just call it 2 over root 3 is fine with me. Delta math's probably going to make you rationalize it. Is it positive or negative? All students take calculus. Cosine is positive, therefore sine is negative and its reciprocal is negative. I want you to notice that this negative sign has nothing to do with this negative sign. Unfortunately, both of those turned out negative. I wished it hadn't. What if I had gone, I don't know if you've done one yet. But you see if I do negative something and land there, everything in there is going to be positive. The negative angle just tells you which way you're rotating. It doesn't have anything to do with your sign. Okay? You got to wait and see what quadrant you spin into. Question? Okay. All right, now let me tell you this, and please somebody send me a reminder about this. One of the things you'll have for homework, not the only thing, but one of the things you'll have for homework is a quiz on worksheets 1 and 2. I'll ask you just like 10 questions off of the worksheets, okay? Or it may even be a Delta Math quiz, because I think Delta Math went all the way through worksheet 2, knowledge-wise. And I'll open that up again to where you can practice on Delta Math. Please somebody remind me to send out the answers to the second worksheet, so you can do that. I think y'all are ready for that. So I'll open up Delta Math. You can, but we're not done. Don't pack up anything. And I'll put that on assignments. Lindsay? Nicole, will you remind me?
Yeah.
Thanks.
Will we be able to use our memo page on the quiz?
No, you won't be able to use your memo page, so, before you get in here, like tonight or tomorrow night, see if you can write down what you want for the quiz, okay?
Or like a flash. Oh.
You can just write it at the top of the page.
Oh.
Like when I hand you your quiz, you can have your pencil ready to write down stuff that you've memorized. I'll kind of remind you on the first one what you probably want to know. Like I would say, put the all students take calculus, if you remember that. Put the 1, 2, 3 chart. Put the IOU chart, okay? But Lindsay, what would be a great idea, everybody? Practice Delta Math with your sheet out. And then put your memo page away and see, and then get out a blank sheet of paper and see if you can do it without that, okay?
And this is going to be a Delta Math quiz or a paperless?
Probably Delta Math, just because so much easier for me, and it gives you a little relaxation.
Yeah.
Just email you about worksheet 2, right?
Yes, just answers to worksheet 2. Thanks, Nicole. Okay, now, Zeta?
This will be for next term, right?
Quiz will be in the next class, but I'll make sure that I, put everything.
It's okay.
Hey!
How are you?
Wow!
I came to say hi.
Hi! Sorry, I'm right in the middle of teaching Radians.
Yeah.
I'll give you a hug.
I can come back. Hi. Duke is amazing. Yeah, and I definitely love it. I'm just here to say hi to everyone.
Okay.
Good.
So,
Yeah, I'm a follower. Like 5 more minutes. Because I started mid-August.
okay.
Yeah.
How many degrees is this? Right here. How many degrees? 180. All right. How many radians is this? By the way, you are not writing on your memo page. In fact, you don't have to write anything right now. Just watch. Remember, I'm sorry, I say that a lot, and I like that you take notes, but sometimes it's better just to watch. If you want to write it down, that's fine, or remember, you can just look at the very end of the video and get this. All right, Rebecca, you told us this was pi over 2. It's real important because it's 90 degrees. Let me convert it. Pi over 2. If I want to convert it to degrees, I multiply by 180 over pi. The pi's cancel, and do you see how nicely that works out? Okay, so what is this? I'll take that. 45 degrees. Pi over who? Pi over 4. All right, so this is 1 pi over 4. 2 pi over 4. What is this one? 3 pi over 4. It's also 135 degrees. 4 pi over 4. Did that work? Good. 5 pi over 4 is 225. 6 pi over 4. What is 6 pi? Well, we had already verified that, right? What am I on? I think I'm on 7 pi over 4. 7 pi over 4s. Did y'all see how I went 1, 2, 3, 4, 5, 6, 7 pi over 4s? That's why radians are so cool. I'm just counting by 45 degrees. If you see pi over 4, guess what your reference angle is? 45 degrees. Look at them. Aren't all of these 45 degrees away from the axis? That's one great thing about radians. 7 pi over 4 is 315. Let's stop and convert. 7 pi over 4, convert it to degrees, is 180 over pi. The pi's cancel. This is a 7. 4 goes into 180 45 times. And if you say 45 times 7, do you see you'll get 315? I hope. Did I do that right? Yes. Okay. So what's the next one? 8 pi over 4, which indeed is 2 pi or 360. And then I don't need to go on because you start the cycle all over again. All right. What about this one? Each one of those red marks is 30 degrees. 30, 60, 90, 120. Let's write that. 30, 60, 90. Does that coincide with what we've learned today? 120, 150. What's 30 more? 180, 210, 240, 270. 30 more is 300, 330. Those are real important angles you've seen. How many radians is this? Pi over 6. I took pi and divided it up into green, 1, 2, 3, 4, 5, 6 equal parts. This one's pi over 6. So what's this one? 2 pi over 6, but what would you call that? Pi over 3. Let's pause and make sense of that so that you'll really know it. Pi over 3 is 180 degrees divided by 3. Shouldn't it be 60 if you do a quick conversion in your head? Okay. So next is where am I? Oh, this is pi over 6. 2 pi over 6. Is this 3 pi over 6? So that works, right? 3 pi over 6. What are you going to write for 4 pi over 6? 5 pi over 6? 6 pi over 6? 7 pi over 6? 8 pi over 6? Sorry, I got ahead of myself. 4 pi over 3? 9 pi over 6? 10 pi over 6, 11 pi over 6, and 12 pi over 6. All right, now in purple, what do you notice about all the pi over 6s? What do you notice about all the pi over 6s? They're all 30 degrees away. All of the pi over 6s are 30-degree bow tie. All right, what about all of the pi over 4s? No, pi over 4s? 45s. And the pi over 3s? All right. Yeah, you could take a picture up. Do it quickly because I got 2 more minutes. But it's also going to be there for the world to see. No one ever looks at my page. It's really actually embarrassing. I didn't expect anybody to take a picture of that. Okay, so, all right, girls, give me my last minute. Look, look, look. Look, look, look. There's 2 things that I want to show you. Here's a much prettier version of it. This is what other classes use. They use the unit circle. I don't. I just rely on all of this to tell me all of this, okay? But also, on their unit circle, they also have to write all the sign, cosine, and tangent numbers. It just gets real messy. So I'm not a big fan, but there it is. All right, last thing I'm going to tell you. On your homework, I know that some of you on your homework will convert to degrees by multiplying by pi over 180. Or you could also try just to do your homework in radians. You'll just have a little bit of homework so you can study for the quiz. But also on my page is this. I'm hurrying because I know we have. There's practice trig. There's a couple of things you can do to just do self-practice, okay? Under links, it says practice trig values if you want to do that. But I'll give you Delta Math and the answers to worksheet 2. Homework will probably be worksheet 3, possibly worksheet 4.